The scope of this project is to model the buoy, anchor chains, vessel, hawsers, floating hose and subsea hoses. I use software applications such as OrcaWave and OrcaFlex. OrcaWave for ship motions like RAOs and QDFs, which are response amplitude operators and quality transfer functions, and OrcaFlex for mooring analysis. And the analysis performed are the static analysis and dynamic analysis in two domains, frequency domain and time domain, to understand the difference of how the results will be depicted from both the domains. And the analysis case is the intact operating condition for 1 year storm. Guess what is single point mooring system? Single point mooring system, the main purpose of it is to load and unload the cargo where the port facilities are not available or very minimal. It connects oil offloading and loading near the shore. The main advantage of single point mooring system is that it weather vanes according to the waves and by reducing the tensions in the hawsers. This is the buoy model which was designed by me using these geometrical properties, and these are the hydrodynamic coefficients used. I use fuel mechanism to this buoy consists of two parts, which are turntable and the another normal buoy part. The turntable is used to weather vane the system. This turntable connects. This is the hawser arm, hose arm, and the boat landing arm, which is helpful here. Here we can see the people working there, and the hawser arm is used to connect the vessel to the hawser with the buoy, and the hose arm is used to connect the floating hoses with the vessel. These are the hydrodynamic coefficients which are calculated by me, and the zero mechanism is used in between to mix it both of them, as the zero mechanism helps in rotating the turntable. This is the anchor line model which was designed by me. This is given by the company which was done, but I haven't given the details because of complications. And these are the chain properties used, which are anchor chain properties. The basis is 95 mm, which is standard chain of RPS grade of linear mass 181 kg per meter, and length per edge will vary. And I also designed the VLCC carrier, very large crude oil carrier, and it is designed using these properties: the dead weight, length overall, beam, depth, and cracks. Both graphs are been designed. And these are the position and mass properties of the vessel, which was given by the company itself. And these are the OrcaWave results, which are RAOs, load RAOs. Only I have depicted here the load main angle RAOs. There are 0 degrees at surge, heave, and pitch, and sway at 90 degrees and roll at 90 degrees, and yaw at 45 degrees, which are high positions, maximum positions, and the same as QDFs, quality transfer functions, which gives us slow angles and slow drift values, where surge and sway are being depicted. And these are the added mass and damping values. And the projected areas calculation of drag loads, which are calculated using the formulas. Thus, this affects FIFZ, that is half coefficient of surge into density into velocity square into area of the surge. These are the surge areas calculated using the underwater volumes. And these are the wind and current coefficients of the vessel. These are taken from the MEC 4, that is Mooring Equipment Guidelines 4th edition, which was given by OCIMF, Oil Marine International Forum. And this is the hawser design. This hawser is used to connect the vessel and the buoy. It helps in maintaining the tension, and it helps in the positioning the vessel. And the hawser types are given here. It is a twin 15-inch circular nylon hawser with of nominal diameter of 120 mm, of length 55 meters. Two hawsers are connected here with chains. And this is the stress strain curve use of hawser. This is also given by the company itself. And the floating hose is this. The main diagram was removed from it because of constraints. And this is the small part of it. One floating floating hose of small part. These floating hoses, when connected with different parts, are called strings. And those strings, total, I think I use 25 strings in one floating hose and 28 strings in one another one. And this is, I performed an analysis and I used these results. That is, in an Excel, I drawn this, the same one. This is the floating hose inner and outer diameters, and this is the inner sheeting, and this is the outer sheeting. This layer is of composite material. The hose is made up of composite material. The sheeting is made up of polymer plate. And these are the subsea hoses which are designed using the same properties given. And this is the assembled file of mine. This is the buoy, and these are anchor chains in all other directions, which was shown in the before one. And this is the vessel, and these are the floating hoses. And the environment conditions used are this: the main sea level water depth of 37.9 meters is used, and the max operating storm of 1 year storm of the parameters is used. This survival I haven't conducted. This is used for fatigue phenomenon. Because of time constraint, I haven't done this. I also used the waves which are used of John-Sharp spectrum of gamma 3.3, and wind is modeled using NPD irregular NPD spectrum. And this is the main direction used, that is waves, wind and current direction, different directions with aligned as one anchor length or halfway between two anchor lengths. I use 0 degrees constraint because it is halfway between two anchor lengths. And if a small wave is connected, given there, the floating hose moves like this. This is the yellow color one is the floating hose, and these are the subsea hoses. The buoy is also modeled like this. When wave is given, it comes like this, a small wave of some parameter. And I think videos are not happening here. And these are the results graphs which were given, given by the software for me of the same phenomenon used. This is the Hauser effective tension for the whole simulation of Hauser effective tension versus the time graph. This is the anchor length effective tension of fifth, which is the maximum one. And this is the floating hose maximum end shear force of whole simulation at end A. And these are the buoy expressions which are performed when wave is given, the wave which was the main sea level and the wave conditions which are given. And in the frequency domain analysis, these are the values I have got. In the frequency domain analysis, we first do the static analysis, then with the standard deviation also be connected with the LF. Then maximum most probable values will be taken from that, and the factor will be calculated. The factor will be same, at most same in everything. Then the standard deviation of wave force. This is the low frequency and this is the wave frequency. Two are differently taken, and this is the most probable maxima in wave frequency. I use Taylor distribution for this, and these are the factors. And for in this frequency domain analysis, we used to use the static response plus low frequency motion plus wave frequency motion. I have got these values, and the minimum values are this. The value from the report, which was given by the company, are this, and the safety factor of connected by this. The minimum safety factor, I think I used API rules and DNV rules for checking. And this is the.
See, don't go into the details of this.
Okay. And these are the results verification of time domain analysis and frequency domain analysis. And I studied both frequency domain analysis and time domain analysis, and I got the results. These are the frequency domain analysis under-depicted the responses, but time domain analysis gives the maximum one. I also use the effective time step and tolerance solvers. That is, I use two different time steps and two different tolerances for obtaining the results. When the tolerance is reduced from 25 e power 6 to 25 e power 4, the outcome was very fixed. But The implicit simulation has been failed, and then I used explicit simulation. But implicit simulation 0.1 second is failed, so I used reduce the time scale at 0.05, 0.025. Then I got this. The results are compared with everything. I think hawser tensions are some issues are there. I want to resolve it, and these are because of damping issues, which was given some extra by me. That's it. Thank you. This is the analysis performed, but it is not playing because of demo version.